Hello everyone. We have been looking into electrical methods of subsurface investigation. We have seen electrical methods can be broadly classified into three major types, which are electrical resistivity method, electrical self-potential method, and electrical induced polarization method. Out of these three, we had looked into electrical resistivity methods already. Today, we will start with the next major method, which is electrical self-potential method. Right? We have already seen electrical resistivity method. So, what is self-potential method? So, here I have written it is an active method, and the induced polarization method is also an active method. The method which we are going to see now, which is called as self-potential method, is a passive method. What is the difference between active and passive method? We have seen few classes before. Active methods are the methods in which we are going to transmit some signal into the earth, and we are going to study the response of that. That is what is known as active method. In passive method, we are going to just measure some of the phenomena or signals that exist naturally below the surface of the earth. So, self-potential method is one such method which is a passive method. What exactly is self-potential method? Self-potential method is known also as spontaneous potential method. What do we mean by spontaneous potential? We have already seen the self-potential method is a passive method. So, what is passive? We are not going to transmit any signal. So, here we are going to make the measurement of natural currents flowing beneath the surface of the earth, which means naturally the current is generated below the surface of the earth. How does it get generated? It is generally generated due to changes in the electrochemical processes below the surface of the earth. So, this is what generates self-potential. In some of the science and technology exhibitions, we would have also measured the potential that is getting generated within our body, right? There used to be a place where we used to keep our hand, and the meter in between will show what is the electrical potential that our body naturally generates. Something similar to that, here we are going to make the measurement of natural potential that exists beneath the surface of the earth, which is getting generated due to some electrochemical process. Because we are just measuring the naturally present potential, this is the simplest geophysical method which we are going to see during this course. This is the simplest method. So, most simple geophysical method. Why? We are just going to measure the natural potential that exists that can be measured at the surface of the earth. Since natural potential which is generated at greater depths will not reach the surface. So, this method is generally for shallow investigation. Maximum may be 50 meters. Generally, for a depth up to 30 meters only is being investigated by self-potential method. Why? Because the naturally generated potential itself will be very less. Suppose if that potential generates deep under the earth at 500 meters, 600 meters beneath the surface of the earth, which will not reach the surface, ground surface itself. So, the self-potential method is generally used or applicable only for shallower investigations, right. So, how self-potential gets generated, right? Self-potential that is getting generated below the surface of the earth is not very well understood, right. Generally, it is believed groundwater or the water present below the surface of the earth in the pores cause cell potential, right? Because beneath the surface of the earth we have solid material. Apart from the solid material there is water. Also we may have air in the upper part of the subsurface. Then we meet the water table, right? That is the groundwater zone. Beneath the water table is the groundwater zone. Above the water table is the unsaturated zone. So this is the ground surface. This may be the groundwater table. So this is the unsaturated zone. This is saturated zone. So groundwater which is present in the saturated zone as well as water present in the unsaturated zone actually cause the generation of natural potential. How does it happen, right? Groundwater function like a electrolyte, right? That means water present below the surface of the earth function like a electrolyte, and the rocks which contain minerals, they function like a solvent. This actually is not present in a homogeneous manner, right? Amount of water present, amount of mineral present also vary beneath the surface of the earth. So this generates some cell potential. These are all some of the reasons for the generation of cell potential. So cell potential of the formation below the surface hence depend very much on the porosity. So what do we mean by porosity? Porosity is the ratio of volume of voids to the total volume. Suppose if you have a elemental cube filled with some material, right? So what is the porosity? Volume of voids within this 1 meter cube divided by 1 meter cube. Okay. So that is what is the porosity. So if the porosity is more groundwater or more water is going to be present in that zone. If porosity is less, mostly it is going to occupy with the minerals. Electrolyte will be very less. Obviously, so porosity is one of the important factor that control the generation of cell potential. Right. Then second is mobility of water within that zone, right? First is the porosity, which is the indication of volume of voids. Second is how efficiently the electrolyte or that is the water is passing through the pore spaces. So beneath the surface, right, the pores are occupying, these are all solid grains. Within the solid grains, water is able to get transmitted. So mobility of water passing through this formation also control the cell potential. Hence, the generation of cell potential depend also on the mobility of different ions present in the water. So water may have many number of dissolved species, right, many cations and many anions. Their mobility also will be different. Certain chemical ions can easily be mobile, some of them may not be as mobile as the one which we had said first. So mobility control the cell potential. Then of course the concentration, right? In one zone water is having very less amount of dissolved solids. In another zone groundwater may have more amount of dissolved solids. This also causes the changes or gradient in the cell potential. Of course, viscosity, temperature, pressure, all of them control the cell potential that is getting generated below the surface of the earth. So what are all the different reasons are for the generation of cell potential? That means types of cell potential which are given here. One is electrokinetic, thermoelectric, electrochemical, mineral potential. These are all some of the types of cell potential that is getting generated below the surface of the earth. So what are they? Let us see little more detail. First is potential gradients. We have already seen depends on the way in which ions are getting transported, how does the ions getting transported? So, ions are transported because of changes in the chemical concentration of ions in water. Imagine water is not moving at all, but still in one part of this zone you have more amount of certain chemical elements, let us say sodium. In another side, concentration of sodium is less. Obviously, sodium ions will slowly move in order to attain equilibrium. So, this causes the potential gradient. Initially, there will be some potential gradient. Subsequently, after the movement is complete, everywhere the concentration is same. So, electrical potential will also be the same. So, these are all the causes. One is the way in which ions are getting transported, changes in the chemical concentration, heat flow, pressure, that is what we had seen on the previous page. So, all of them causes changes in the potential, right. That is, one is porosity and the within pores how water is moving. If you want to deep dive, the major reasons for the cell potential is, one is mobility of ions, changes in the concentration, viscosity, temperature and pressure, right. Accordingly, we have seen 4 types of cell potential, right. So, first type is potential that is generated due to changes in the pressure, which means water present below the surface of the earth may occur in different pressure, right. One reason for that is the depth. Water at the greater depth is occurring at a higher pressure. It is something like we experience this, right. When we go to a water body, maybe a swimming pool, when you are at the surface, when you just put your head beneath the surface, water surface, then you don't feel much of a pressure. But if you go 5 feet or 2 meters below the surface of water, then you feel the pressure in your ear. The same way, the pressure gradient itself will trigger generation of cell potential. This is known as electrokinesis. Then the second is thermoelectric potential. This thermoelectric potential is generated due to change in the temperature of water as well as the solid below the surface of the earth. We also know very well, as the depth increases beneath the surface of the earth, temperature will also increase. This temperature gradient itself will generate electrical potential. Then the third is diffusion. This is what I mentioned initially, right. That means below the surface of the earth, right. This is the surface of the earth. Let us imagine here concentration of sodium ions is very high, whereas here concentration of sodium ion is less. Will it remain like that always? No, it has to reach equilibrium. So, obviously, the sodium ions will be moving toward this direction. This is at time 1. Time 1, here it is higher, here it is lower. At time 2, right, maybe after several months at time 2, everywhere the sodium ion concentration is the same. Okay. So, during time 1, there is going to be some gradient, right. That is the chemical gradient. This will also lead to diffusion of ions. Ions will start moving. That is, this process is known as diffusion. This causes natural electrical potential. Then the last one is caused by the minerals, right. The minerals beneath the surface of the earth may occur in a particular fashion, as if you have a battery beneath the surface, right. Many of us would have will know what is a battery, right. We are using it for our maybe for a calculator or for the remote control at our home. The battery has a electrolyte as well as a electrode at the center. Naturally, there may be a mineral body which may occur like an electrode surrounded by electrolyte, which is of course the groundwater. This itself will generate current. This cell potential is due to mineralization. These are all the 4 types which we had seen on the previous slide also. That is, one is the electrokinetic, thermal gradient, then this is chemical gradient, last is due to minerals, right. Minerals may occur as if in a structure something similar to what we see in a battery, right. So, what we had seen last is the due to mineralization. So, in mineral exploration, we always look for the fourth type of cell potential, right. In mineral exploration, we look for the mineralization causing some changes in the natural potential, right. So, in mineral exploration, we search for cell potential which is normally negative compared to the surroundings. We are going to see little later, right, maybe in the following slides. So, this is usually associated with sulfide ore mineral deposits, right. Sulfide deposits are very good electronic conductors, right. So, very easily we will be able to locate sulfide ore deposits by cell potential method. So, this is the only situation where we have the fourth type of natural potential, that is caused by the movement of electrons, right, in a fashion that generates current, which we will see in the following slide. So, this is what I was referring to. So, what normally happen in the fourth type of cell potential generation, a ore body may occur in such a fashion, right, like a electrode in a battery, right, surrounded by water, as you see in this diagram, surrounded by water, right. This here you have water. So, this leads to the changes in the potential. So, around the minerals you have water, but at the center we have a ore body, and here too please see the ore body is partly in the beneath the water table. So, this is the water table. So, water table is shown by a dark line which I have drawn, right. So, this is the water table, I am drawing it in red color now. So, this is water table, beneath that it is completely saturated, right. Above the water table is unsaturated zone, below the water table is the saturated zone. So, here is the water table, and it so happened this mineral body is buried beneath the ground surface. This is the ground surface, right. This is the ground surface. Part of the mineral body is in the unsaturated zone, part of the mineral body is in the saturated zone. So, which means above you have a oxidizing zone, below oxygen less zone, that is the reducing zone. This makes, right, the whole region function like a battery. So, the ions are moving like this, right. So, this generates some cell potential. So, ions are moving like this, or the current is flowing as I have drawn. This causes the potential gradient at the surface. Where do you have high potential? Somewhere away from the mineral body. This is the ground surface. Here potential is high. Here too potential is high. Just above the mineral body potential is less. This is what I referred on the previous slide. I will go back. So, here we said in mineral exploration we look for cell potential which will be invariably negative compared to the surroundings. So, here you see on the sides cell potential is less, above the mineral body cell potential cell potential above the mineral body is less, whereas at the sides it is higher. Here it is higher, here also it is higher, here it is lower. So, this is the scale of cell potential. The x-axis here is the distance, right. So, just above the ore body the cell potential is less. So, current passes downward through the ore body and passes upwards outside the ore body, this direction, right. This is what I have put up here, right. So, due to which ground immediately above the ore body has got the lowest potential. This zone has got the lowest potential, right, compared to the sides. So, the region which is having the lowest potential is normally shown written as negative center. We have seen the same in the previous slide. So, invariably the cell potential will be negative. So, above the mineral body you have the negative center. So, when we search for mineral ore body, right, maybe for mining purpose, we obviously search for locations where the potential is comparatively lesser, right, comparatively lesser. That is what is known as negative center. Right. This is what we have seen in the previous slide itself. So, mineral body occurs something like this. So, the ions or current flows around the ore body, causing the higher cell potential on the sides, lower cell potential just above the ore body. Right. What are all the different types? We have already seen different types of cell potential we have seen. What is the anomaly that we are going to get due to the cell potential that is going to get generated below the surface? We have seen already the presence of mineral deposits, right, especially ores of sulfates. All these minerals, suppose if you are a geologist or a mining engineer, our aim will be to look for negative centers. We have seen already in the previous slide, right? That means there is a ore body, right? A ore body occur below the surface of the earth, which causes negative center just above it. This is what we look for, right? At the surface during investigation, you look for negative centers. When you find negative centers, you expect a mineral body present below that place, right? Suppose if you are searching for something else, suppose if you are searching for a large minerals of large size which are normally found in these rocks, pegmatites are known as store well of minerals, especially in India. Large books of mica are mined from pegmatite rocks. Pegmatite rocks has got large minerals. These rocks are formed due to slow cooling of molten magma, due to which minerals are able to nicely crystallize into larger chunks. If you have such rocks, they will lead to positive anomaly, because compared to the surroundings, over here potential will be little bit higher. That means current will be flowing on the other side of these pegmatites, will cause positive anomaly over these rocks. Then if you search for something else, especially if you are trying to locate zones which are having higher amount of geochemical reactions, or looking for locations of groundwater movement, maybe beneath a earthen embankment, they will be usually positive. And depending upon the situation, sometimes groundwater movement beneath the surface may sometimes create positive or negative, but what we actually look for here is an anomaly. So, whether positive or negative will give you some clues about what is happening below the surface of the earth. We will see some applications toward the end of this lecture, wherein you will be able to appreciate the usefulness of positive as well as negative anomaly. How are we going to do the survey? I had told you initially, always we will see something in general, some fundamentals, then we will look into the equipment that we are going to use, how do we carry out the survey in the field, that is the third part. Then the fourth part is how are we going to interpret the data, and the fifth part is the general applications and some case studies. That is how I have organized my lectures for teaching you the different geophysical methods. We have seen already resistivity method in this more or less in the same format. Today we are looking into cell potential method. Until now we have seen some background information. Now let us see what is the equipment which we are going to use. Here too we are going to use only a voltmeter. Ammeter is not necessary, because we are not going to apply any current. We are going to just measure the natural potential that exists below the surface of the earth. That is what we are going to measure. So it is necessary that we just make use of the millivoltmeter. itself is sufficient, right? But we have already learned what is resistivity meter. So, resistivity meter is a combination of both. What is resistivity meter? Resistivity meter is a combination of both ammeter and voltmeter. We have already seen. Since we may be having resistivity meter, we need not bother about this. We will use the resistivity meter for conducting this survey. What we may not use in the resistivity meter, battery part we may not use. So, resistivity meter we have already seen. Resistivity meter is attached to a battery, right? For conducting resistivity survey, we need to make use of the battery, whereas in cell potential method, battery is not necessary. So, it is sufficient we use the resistivity meter, or if we do not have resistivity meter, we can also use the simple voltmeter, right. Then we need electrodes as well as cables. Cables are just similar to the cables we had used for resistivity method. Whereas in the case of electrodes, hope you recollect, previously we had used some stainless steel rods as electrodes. They are like more or less a miniature cricket stumps, right, normally of about 45 centimeter long and diameter may be 2 centimeters. Yeah, it is a circle, right, such which will have a sharp, of course it will have a sharp edge at the bottom. It is for our convenience, right. It is something like this pen with a sharp edge, so that you can hammer this into the earth. But there is a minor difference in the case of cell potential method. So, we do not use this conductive rods. Why we are avoiding the use of conductive rods is, suppose if you put this conductive rod below the surface of the earth, right. So, this is the surface of the earth. When you keep this rod into the earth, beneath the surface, moisture content will vary, water content will be different. This may induce some self-generated potential around the electrode which we have planted. Okay, this situation is something similar to this case, right. Since you have put a metal rod here, this metal rod itself will function like this. The current may be flowing this way around the metal rod. This in turn will generate some cell potential due to our intervention. So, we need to get rid of this. Hence, we do not use a conductive rod, but we use what is known as non-polarizable electrode. That means, around the electrode there will not be any polarization or cell potential generated. So, that is the only change from that of the resistivity meter. In resistivity meter, we used both ammeter as well as voltmeter, whereas in cell potential method, we will just use the voltmeter part of the resistivity meter, and we will use the same cables. Electrode alone will be little different, which is known as a non-polarizable electrode. What is a non-polarizable electrode? So, non-polarizable electrodes are like this, right, where you have a porous part. So, this is a porous part, right. So, porous parts, right, will have a metal electrode at the center. So, this is the metal electrode. So, the metal electrode at the center, whereas the liquid or the electrolyte here is a supersaturated solution of the same metal. Suppose if we use copper electrode, here we will use copper sulfate as a electrolytes in the porous container, right. Why do we use such a container? Because this is a non-polarizable electrode setup. That means, due to this arrangement, there will not be any cell potential generated due to the electrode itself. The bottom of this porous part will have a non-conductor. Usually they may be made of wood. Okay. So this electrode setup produce almost nil or very small amount of cell potential. So almost negligible. Okay. So that is the purpose of making use of this electrode. This is the major difference from that of the electrical resistivity method. Right. Now, how are we going to carry out the survey? So, here are some pictures which showing the non-polarizable electrode. So, these are all the porous part which you can see. This is the porous part, right? And we'll have at the bottom again a non-conductor, maybe rubber or wood. So, this is the picture of a non-polarizable electrode. How are we going to conduct the survey at the field? Right. Survey in the field can be conducted by three different methods, right? Three different methods. Before looking into methods, how are we going to arrange the electrodes? Having already learnt about resistivity method, we very well know how many electrodes are necessary to conduct electrical resistivity survey. How many electrodes are necessary? Can you tell me? So, we need 4 electrodes. Hope you can recollect. I used to always draw something like this: 2 electrodes at the center, 2 electrodes at the outermost, which are known as A and B outer electrodes. Right? This is what is the arrangement I have drawn now? I have drawn Schlumberger arrangement. So, these A and B are current electrodes, M and N are potential electrodes. This is the arrangement we follow in resistivity Schlumberger method. Now we are looking into cell potential method. So, that we are not going to apply any signal into the earth, which means there is no need for these 2 electrodes. We are going to just measure the natural potential. So, 2 electrodes are sufficient. We are going to just make use of 2 electrodes and measure the potential difference between them. Right? How are we going to measure the potential? Using a voltmeter. We are going to make use of the voltmeter to measure the natural potential. So, that is why this method is the simplest geophysical method. Right at the beginning we said this is the most simplest geophysical method. So, here we are just going to make use of just 2 electrodes to measure the cell potential. Right? The survey can be done in these 3 ways. First is tracing the equipotential line. Second is carrying out the survey in grid pattern. In third one, we are going to just determine the potential gradient. Okay. So, about all this we will see in detail in the next lecture. So, today what we had seen, we have taken up the first geophysical method, which is resistivity method, which we are familiar with. We have seen many lectures on this. Today we commenced with cell potential method, which is a passive method. So, cell potential is generated due to 4 reasons, which are: one is due to pressure gradient, then the second is due to temperature gradient, third is due to chemical gradient, fourth is due to minerals. Right? These are all the 4 causes of generation of cell potential. Then we had look into what type of anomaly we will end up in getting, right? Whether you will have positive anomaly. If it is minerals, it is going to be positive. If it is non-minerals, you may either have negative or positive anomaly. That is what we have seen here. Then lastly, what is the equipment that is necessary? Major difference is use of non-polarizable electrode. Then lastly, we had seen how the survey is going to be carried out at the site. We will continue with how the field survey is going to be carried out in the next lecture. Thank you.